Welcome to this video for College Algebra Chapter 1, Sections 1 and 2. This is on the topic of solving linear equations. So the first thing I want you to do as you're watching this video is pause for just a second and try to solve this equation. Let's see what your skills are at this point, and I'll give you just a few seconds to pause. And now let's start back up. So we'll see how you did at solving this equation. There are kind of two approaches, standard approaches to solving an equation like this. So the first approach would be to start simplifying this left side. I start with parentheses. Remember, we've got this order of operations, parentheses or grouping, exponents, multiply, divide, add, subtract. This is what we call the order of operations. So I start working my way through this. I can't do anything with this grouping x plus 7. So the only other way to deal with this parentheses is to multiply. I'll distribute a -2 times x and distribute a -2 times 7. Now nothing else in this equation has changed. Let's simplify some more. The like terms inside this bracket, 25 and -14, can add up to 11. So this is -2x plus 11 inside the brackets. I have a 3 out here. I have a plus 5 out at the end. According to our order of operations, again, I just did some multiplication. Lower on the order of operations, the last priority is addition, so I'm going to save this plus 5 for later. Let's do this multiplication. 3 times this bracket's -6x plus 33 plus 5 equals 17. Now I can finally get down to my last part of the order of operations, adding and subtracting. I'm going to add these like terms, and we'll get -6x plus 38 equals 17. So at this point, after I've simplified, I need to reverse my order of operations. I'm going to start undoing things to try to get at this x, this variable, this unknown. So I want to undo things. Now, when I'm simplifying, I need to follow the order of operations from top to bottom. When I'm undoing things in an equation, I'm going to follow the order of operations in reverse. So for simplifying, follow the order of operations. For undoing, which is one of our key skills in solving equations, for undoing, we'll do things in reverse order of operations. So I see this plus 38 as addition. I want to undo addition first. So we'll subtract 38 from both sides. We get -6x equals 17 minus 38. That is -21. And finally, the next thing I'm going to undo is multiplication. So I'm working my way up the order of operations. Undo multiplication by division. Divide both sides by -6, and simplified, -21 over -6 is the same as positive 7 over 2, or in decimal form, 3.5. Okay, well, before we go on to some more examples of solving linear equations, I do want to go over a couple of things. First of all, question, what does the word linear mean in linear equations? I'm calling these things linear equations. Well, the linear part of this has to do with the fact that a graph of an expression like this is a straight line, and a graph of any linear equation will be a straight line. Kind of leads to this other question, what kinds of equations could there be that are not linear? So there are a lot of different answers to that question, but a couple of important things is we shouldn't expect to see any variables up in the exponent as a power. We shouldn't expect to see any trig functions like sine or cosine or any square root functions. In fact, we should not expect to see any powers of x besides first power. Linear here refers to the power of x being only x to the first power. So we shouldn't see x squared or x cubed or anything like that. Those we'll save those kind of equations for another lesson. So here are a few tips for solving linear equations. These are not all the rules that you could possibly follow for solving equations, but they do get you pretty far in solving. So we've seen already an example where I simplified one side of an equation. A lot of times they're simplifying to do on both sides of the equation. So that's often a good step, a good first step for solving a linear equation. When we undo things, that is undoing addition and subtraction, undoing multiplying and dividing, you undo things in the reverse of the normal order of operations. So we'll start by undoing addition and subtraction. We'll follow that by undoing multiplying and dividing. Maybe follow that by undoing exponents, although we won't see that in linear equations. And the last thing we'll undo is grouping symbols. So if we see an x that's inside of a grouping symbol, we've got to do a lot of work to get at that x. Here are a few more tips that will help you in various situations. Multiply by an LCD, or lowest common denominator, to clear fractions or decimals. Use addition and subtraction to move terms from one side of an equation to another. We'll see this when we see x's on both sides of the equation. A lot of times we want to move all the x's to one side, all the numbers to the other. You use addition and subtraction to accomplish that. And use division to strip away a factor from a term. So when we have a 3x, for instance, if I want to leave the x on the side that it is and just get rid of the 3, I'm going to divide by 3. And finally, take care with positive and negative rules. When you're distributing, in fact, just about any time, take care when you're dividing by a negative, when you're multiplying by a negative, if you're adding and subtracting positives and negatives, just pay attention to those kind of details. Well, I have several examples to show you that will illustrate some of these concepts. As you watch the video, feel free to pause, rewind. Anytime you are unsure of how to get from one step to another, watch the video again and kind of listen to the explanation, and hopefully that can clear things up for you. So here are a couple of first examples to start with. I'll start with some fairly easy things. Solve 5x minus 4 times parentheses x minus 6 equals negative 11. I'm going to focus on simplifying this left side of the equation. So 5x and negative 4, they're connected by subtraction, but 4 and this parentheses are connected by multiplication. So when I'm simplifying, I want to do multiplying before I try to do adding or subtracting. I'm going to distribute a negative 4 into this parentheses. Here's where we need to pay close attention to positive negative rules. Get negative 4x, and we get positive 24. So that's our first step in simplifying, is distribute. Next step would be to combine our like terms. 5x minus 4x plus 24. This is all addition and subtraction. These two are like terms, add up to x plus 24 equals negative 11. I'm going to finally undo some things. Now that I've simplified this side completely, subtract 24 from both sides, and x is isolated on this side, equal to negative 35 on this side. This equation is solved. Let's go on to this next example. We've got 3 times a quantity minus 2 times a quantity equals 4 times a quantity. Looks like there's lots of simplifying to do on the left, a little bit of simplifying to do on the right. So let's start distributing. 3 times this parentheses gives us 6t minus 3. Remember, this is a negative 2 distributing into here. We'll get negative 10t minus 2. It's Very common mistake for people to remember to multiply the negative on the first term and then forget that you're multiplying by a negative here and accidentally put a +2. But remember, it's -2 times +1. That's -2. Simplifying the other side, we've got 12t plus 16. All right, there's still a little simplifying I can do on this side of the equation. I can combine my like terms. 6t and -10t equals -4t. -3 and -2 is -5. So I've combined those like terms. Now notice that there are terms that have variables on both sides of my equation. This is when I'm going to use addition and subtraction to move a term from one side to another. You can either try to get all the t's on the left side or all the t's on the right side. Either way will work. I sometimes prefer to get my t's to come out positive. So I'm going to add 4t to both sides. Now I have -5 is equal to 16t plus 16. I would like to get all my numbers on the other side of the equation. I'm going to subtract 16 from both sides. And now I have -21 on this side equal to 16t. I'm almost out of room here, but it's a good thing I only have one step left. I'm going to divide both sides by 16 so that I can strip away that 16 from the t. And so t is going to equal -21 over 16. Notice that I added and subtracted to move an entire term. If I want the t to come along with this 4, use addition and subtraction. If I don't want the t to go away, if I only want to get rid of the 16, use division. For this next example, I'm going to simplify the left side again and then start undoing things. So I see parentheses times parentheses, 2 binomials. I'm going to have to FOIL those. First, outsides, insides, last are going to multiply and equal 6y squared minus 4y plus 3y minus 2. Wait a minute, 6y squared. This is starting to look quadratic. This looks like a quadratic equation, not a linear equation. What's going on here? Well, don't panic yet. Let's just keep going and see what happens here. Foiling these next 2 parentheses, I get 6y squared plus 24y minus 1y and minus 4. But remember, I've got this negative sign here to distribute through these. So that's going to change the sign of every term in this parentheses. I'll get the original 4 terms, and then a minus 6y squared, a minus 24y, a plus 1y, and a plus 4. So it turns out these quadratic terms actually cancel each other out. They add up to 0. And I do wind up with a linear equation. Let's collect all the rest of the like terms. If I look at all the y's and try to add them up, I'll get that y is, the number of y's I have here is -24y. Collect the constant terms together and we've got +2. So far I was following the order of operations. I multiplied, then I added and subtracted. Now I'm going to try to undo things. So I'm going to go reverse order of operations. Do the addition subtraction first. I'm going to subtract 2 from both sides and finally divide both sides by -24. So I get y equals 11 over 12. This next example is going to illustrate a way of dealing with fractions. A lot of people don't like to have to combine fractions, add, subtract, multiply, and divide them. They have a hard time with that. And so what we've got is a strategy that will clear this equation of all of its fractions. The key to accomplishing that is multiply both sides of the equation times the lowest common denominator. That lowest common denominator happens to be 28 in this case. That's a number that 4, 7, 14, and 2 will all go into. So I'm going to multiply both sides of the equation by 28. Essentially, I'll multiply every term times 28. The result is going to be an equation without fractions. So how does this result wind up coming from multiplying by 28? Let me break this down a little bit better here. We're going to multiply the first term times 28. 28 times 1/4 is just 7. 28 and 4 you could think of as reducing to 7 times 1. 28 times 5x gives me the 140x. Now, what about this? The 28 times x over 7. When these 28 and 7 get together, they're going to cancel out and become a 4. So I only multiply 4 times x. On the other side of the equation, when I multiply times 28, the 28 and 14 will reduce. So I only wind up having to multiply 2 times 5. When I multiply x over 2 times 28, the 28 and the 2 cancel, and so I really only have to multiply 14 times x. If you kind of analyze this, you can see that what I wind up multiplying this numerator by is whatever this denominator was missing to get it up to 28. So 4 times 7 is 28. I multiply that numerator times 7. 7 times 4 is 28. I multiply this numerator times 4. 14 times 2 is 28. I multiply this numerator times 2. 2 times 14 is 28. I multiply this numerator times 14. So in essence, each numerator gets multiplied by whatever this particular denominator was missing. So what do we do now? We've got x's on both sides. Let's simplify a bit and try to solve this. Simplify the left side, 7 plus 136x. Simplify the right side to 24x. Get all the x's on one side of the equation. So I could subtract 136x from both sides. Finally, divide both sides by negative 112. 7 over negative 112 actually reduces to negative 1/16, or in a decimal form, negative 0.0625. So that's the way we're going to deal with fractions. We want to multiply times the LCD. If you perform this operation correctly, you should wind up with no fractions in your new equation. Let's look down to this next example here. Let's see, we've got some simplifying to do on the left side. Distribute this negative sign through that parentheses and then maybe combine some like terms. On the other side, I've got distributing to do as well. Combine these like terms and I wind up with a positive 2y and a negative 4. All right, we've seen y's on both sides or variables on both sides of an equation before. Usually we add or subtract to move terms from one side to the other. So maybe I want to move this 2y over to that side. I'm going to subtract 2y from both sides. And wait a minute, 2y minus 2y is 0. 2y minus 2y is 0. I got this crazy statement here that negative 4 equals positive 2. Well, that's clearly a nonsense statement. What has happened here? The way we're going to interpret a situation like this is to say that this equation has no solution. In fact, there cannot be any y value that will ever make this original equation true. There's no solution. Let me give you a kind of a breakdown of the different situations that we can run into if we're solving a linear equation. So linear equations can fall into these three categories. One solution. The technical term for that is conditional. So it's a little bit of vocabulary you should get familiar with. That's the typical kind of equation that we saw in most of our earlier examples, where x was equal to a single number, and that one number was the only number that could possibly make that equation true. The situation we just ran into, we call no solution or inconsistent. For inconsistent, the way we recognize that is we'll go through the process of solving the equation and we'll wind up with one number equal to a different number. Now that can't possibly be true. 5 can't equal 7. Negative 6 can't equal 13. If we have one number equal to a different number, that statement is nonsense. That tells us there was no solution for that equation to begin with. The third possibility is something called infinite solutions, or we also use the term identity. And the way we recognize these is After going through the process of solving, we'll have one number equal to the same number. All the x's can cancel out, leaving us just with a number equals the same number. Let me show you an example of that infinite solutions possibility. So here's an equation. I'm going to start simplifying. If we simplify the left side, we get 8 plus 12r minus 2. If we simplify the right side, we get 2r plus 10r plus 5 plus 1. Collect your like terms on the left, you get 12r plus 6. Collect your like terms on the right, you get 12r plus 6. If we try to move the r's from one side to the other, subtract 12r from both sides, we wind up with 6 equal to 6. Well, of course 6 is equal to 6. When is 6 equal to 6? Every day. For what values of r is 6 equal to 6? Any value of r is going to make 6 equal to 6. When r equals 7, 6 equals 6. When r equals 115, 6 is still going to equal 6. If r equals negative 6,000, 6 is still going to equal 6. So any possible value for r can make this original equation true, because the original equation basically just tells us that 6 is equal to 6. So we interpret that as infinite solutions or an identity. For our last few examples of solving equations, I want to go back and focus on these equations that involve fractions, because they tend to be the kind of equations students struggle with the most. We're going to start with this equation, 1 over 3x plus 1 over 2x equals 1 over 6 minus 1 over x. These denominators, 3x, 2x, 6, and x. The lowest common denominator that I could find for these different denominators would be 6x. All four denominators will go into 6x. So I'm going to multiply each term in this equation times 6x. In each case, a lot will cancel out. 6x over 3x winds up reducing to a 2. So really, I only need to multiply 2 times 1. 6x and 2x reduce to a 3. All I need to multiply 1 times is 3. And 6x and 6, when these 6's cancel out, all I wind up multiplying this 1 times is x. And finally, 6x and x, this time the x's will cancel out, meaning I multiply 6 times 1. Now don't forget this minus sign here. That was important too. It stays a negative. So negative 6 times 1 is negative 6. This turned out to be a very simple equation. 5 equals x minus 6. Add 6 to both sides of the equation, and we'll see that x has to be 11. Another example with fractions. Let's clear these denominators. 5x minus 3 and 4x minus 1, the LCD would equal 5x minus 3 times 4x minus 1. When I multiply this left side times that lowest common denominator, the 5x minus 3's will cancel out. So I really wind up multiplying negative 2 times only 4x minus 1. Remember, it's that concept of what is this denominator missing? That's all the numerator has to multiply by. When I multiply this right equation times the LCD, the 4x minus 1's will cancel, and all that's left for this 4 to multiply by is 5x minus 3. Now, this multiplying by the lowest common denominator technique, in this kind of situation, also looks like something that you may have heard of before, cross multiplying. We wind up multiplying negative 2 times this denominator and 4 times the other denominator. So cross multiplying is really just a illustration of multiplying by the LCD. So let's continue solving this equation. Distribute the -2, -8x plus 2. Distribute the 4, 20x minus 12. Let's get all the x's on one side of the equation by adding an entire term. Add 8x to both sides. We have 2 equals 28x minus 12. Now I'm going to get all the numbers to one side of the equation by adding 12 to both sides. 2 plus 12 is 14, so I have 14 equals 28x. Divide both sides by 28, and our answer is that x is equal to 1/2. 14 divided by 28 is the same as 1/2. This next example is yet another example with fractions. You can hopefully see here that the lowest common denominator for all three of these fractions is quantity x minus 2 times quantity x plus 2. What we're going to notice here, though, is something strange. We're going to solve this equation, but at the end, we're going to see something called an extraneous root, or a solution that really doesn't fit the problem. Let's see what happens here. If I multiply by the lowest common denominator, each term times x minus 2 times x plus 2, lots of canceling happens. X minus 2's cancel, so this becomes x plus 2. X plus 2's cancel. This one becomes x minus 2. Both quantities cancel here. The right side of the equation is just 4. This is actually a pretty easy equation to solve. I have 2x. The numbers add up to 0, equal to 4. If 2x equals 4, that seems to indicate that x should equal 2. But here's a problem. Try to plug 2 into this first expression. I get a 0 in the denominator. 0 in the denominator is undefined mathematically. There is no number that equals 1 over 0. So immediately, if I try to use that solution, I get something undefined plus 1/4 equals something else undefined. This also turns out to be 4 over 0. That is not a valid equation. Undefined plus 1/4 does not equal undefined. That really doesn't tell us anything here. This is an example of an extraneous root. Doesn't mean I did anything wrong in solving the equation, but just sometimes when we use this technique, our solution doesn't really fit the problem. So I would suggest if you solve an equation like this, especially with multiplying by the LCD, test your answer to see if it really does fit into the original equation and can produce a true statement. My last two examples are examples of what we call solving literal equations, or solving a formula for a variable. This equation does not have a single x that I'm trying to solve for. It's got all kinds of variables or letters that could represent quantities here. We've got a and capital P and little r and little t. In these kind of problems, they're going to give you directions to solve for one of those variables. In this case, they want us to solve for t. Well, the key is to treat every variable except for t as a constant. That is, treat a just like a number, treat p just like a number, and treat r just like a number. So let's kind of follow the same process we've been following all along. We're going to simplify the right side and then try to isolate this t, try to undo the order of operations until t is by itself. Distribute the p, that's how we simplify that right side. We wind up with p plus PRT. Next step is to try to isolate this r. Remember, reverse the order of operations, so I'm going to undo this addition first. I'll subtract p from both sides. Next, I'm going to undo multiplication. I'm going to divide both sides by PR. And the result here is that I've isolated the variable t. Another way of saying that is that t is now a formula in terms of a and capital P and R. Our last example here. Solve this formula for h. Ooh, I have two terms that involve h. So here's a little trick. If we have two terms that involve the variable we're trying to solve for, we're going to do some factoring. I noticed this is kind of what I call the first kind of factoring. I factored out what they have in common. They both have a 1/2 in common. They both have that h in common. Now I need to start stripping things away until this h is by itself. Wouldn't hurt to clear these fractions. Let's multiply both sides of the equation by 2. And finally, to get rid of this entire quantity, b1 plus b2, I'm going to undo multiplication. Remember, this is h times this quantity. So I'm going to divide both sides of the equation by that entire quantity, b1 plus b2. We wind up with h as a function of capital A and b1 and b2. Thank you for watching this college algebra video. Hopefully it will be helpful to you as you try to solve some linear equations.